Hi, my name's Dave Milton and today we're going to have a very quick look at feedthroughs. Today we're going to look at the key features and benefits of these. We're going to be looking at the part codes and how to fit these. On the table we've got the feedthroughs we're going to talk about today. These are the instrumentation feedthroughs that fit to all our manipulators. We do sort of two main types, which is the inline and the right angle. The right angle is the most common one we use. The inline is the ones you use on cryostats or somewhere where it's going to be mounted vertical, so it doesn't catch the side or the back of the HPT as it rotates. These two here, we have the power one, you can see that because this has got barrels on it, and this one, which is the thermocouple one, which has loops on it. This one here is the inline one, which I've mentioned, and this one has got the barrels, so this one is for the power. So we'll just explain a bit about the part codes. These always start with ZEFT 924, which is the version. And then at the end we have some letters, which is either an I, S, T or X. If it's got an I at the end, then it's the inline version. So that would be a ZEFT 924I. Then these versions come in three types, the S, T and X. The S has the legs on the inside 75, the T are 40 and the X or 20. Normally the 20mm ones, which would be the ZEFT 924X, would be fitted to the OmniAx, and the ZEFT 924T will be fitted to the HPT, MiniAx and Transax. The same goes for the part codes for the power. These are ZEFT 9H4, and at the end again they have the I for the inline version with the 22 long pins, and then these have the S for the 75, the T for the 40 and the X for the 22. The wire we use to connect to the heaters on these are a 0.9 single-stranded silver-coated wire with a PTFE sleeve. The wires that are used on here that's under the sleeving is 1.22 nickel wire. When you fit the wire to the feedthroughs, it's very important that you get a very good contact. As I mentioned, it's dedicated wire all the way through. With this wire you strip off the PTFE, which is a very thin coating, and you literally wrap the wire around the loop, and then you trap the wire using a screw or washer through the loop and then another washer and a nut to make sure the wire has got a very good contact. You will notice that the plugs are different on these ones. If you look at the power one, that is a female plug. The reason for this is the power is coming down the wire, so you don't want to be able to touch the pins. On the thermocouple, they're male. The reason for this is the power can come back up, which is from, if you're using something like an E-beam heater, you can have as much as minus 650 volts come back up the line. So you need to make sure you can't touch the pins if the plug is disconnected. One of the key benefits of our feedthroughs is they all comply to EU regulations, and these are bakeable to 230 degrees C. So another key benefit is the dedicated plugs that we use on these. On the thermocouple we use the LEMO, and on the power feedthrough we use the Fisher. These will just lock on and they're not easily removed. Going into a bit more detail on the power feedthrough, these have 4 pins, and I'll explain what the pins do. If you've got a resistive heater, which is a wire heater, or a PBN, then we only use these two. This is the positive and this is the negative. Sometimes customers will use a third pin, which will be this one, which can be ground on the sample plate, but you can use these 2 pins for whatever you wish. So we looked at the part codes for the K-type, where we'll do the N-type in a minute, but I'll just go into a bit more detail. To know which pin is which on these, on the flange is marked T1 and T2. The T1 is the positive, which is the non-magnetic leg, and this will be the green. The T2 is the negative, which is the magnetic one, which is white. The part codes on the N-type are slightly different. We actually drop the 2 from the part codes. So if this was the K-type, it would be a ZEFT924X. But now we're talking about the N-type. We drop the 2, and this will be a ZEFT94NX, which is a 22mm leg. The ZEFT94NT is the 40mm leg, and the ZEFT94NS is the 75mm leg, and the inline version would be the ZEFT94NI. On the N-type, the flange will be marked N1, which is the positive, the pink, and the N2, which is white, and the negative. To tell the difference between the positive and negative legs on the N or K type, the longer leg is always the positive, and the shorter leg is the negative. So this is one pair, and this is your other pair. So that gives you 2 pairs of thermocouples. So the last of the feed-throughs we're going to mention is the one that's used for the electron beam heaters, and that actually only has 3 pins. This 4th pin actually isn't used on this one at all. The connection inside goes directly to the body, so all you see is just these 3 pins. On this one you have the positive and the negative, and the ground, which goes to the sample plate of your heater, and the reason being is it draws the electrons forward when the heater's running. The 4th pin, which I mentioned, isn't part of the EFT for the electron beam, is to operate the interlock on the EBHC, which is our electron beam controller. So what happens if you haven't got the plug connected to your feed through, then you cannot apply the high voltage. As soon as the plug is connected, this opens the interlock in the EBHC and allows the high voltage to be powered down to the electron beam heater. Just to explain a bit more, just in case you're not familiar with the type of thermocouple wire, you can see this is green and white. This is a DTC1K, which is the K type. There is also a pink and white, which is DC1N. So I hope you enjoyed this quick video on feed-throughs. We looked at some of the benefits, the part codes and how they should be used. If you enjoyed this video, please subscribe to our channel. Thanks for watching.